Carrollton High School. And they're going to share with you about STEM in their school and what they are doing with it and where they're going with it and how they're getting ready to be college and career ready for STEM. So I would like to welcome up these two, Arizona and Brendan.
Hi, good morning everyone. I'm so excited to be here. It's a huge honor to have been asked to come and speak with all of you guys. So, as she said, my name is Arizona. Brendan, he's going to be presenting after me, so he'll come up in just a little bit. Just a little bit about me before I start into all the STEM aspects of my life. I am a senior at Carrollton High School. I've been at Carrollton since, I guess, first grade, so born and bred Trojan. I'm involved in a lot of activities there. I'm on the varsity volleyball team. I'm involved in student council, president of Key Club, and a lot of other activities. So I do have a life outside of all of the STEM things, but STEM is definitely a huge component of what I've done. These are pictures of me and my little brother, who's currently a freshman at Carrollton, and then also me and my mom. She's a speech pathologist at Central Elementary School, and I believe there are actually some people here repping Central Elementary, so she's excited about that. But I guess STEM for me really started in the 6th grade when I was approached by Gwen Benson. She was our science club mentor during middle school, which was 4th and 5th grade in Carrollton. And she came up to me one day and pulled me out of class and said, "Hey, what do you think about starting an underwater robotics team?" And naturally I said, "What?" Because I'd never imagined doing anything with robotics, nonetheless underwater. And so even though I literally had no idea what I was getting into, she seemed so excited about it. I thought it sounded like a lot of fun, so I decided to give it a try. This is a picture of me, junior high Abby, with braces and everything. Yeah, I was cute, right? This is one of the earliest versions of our ROVs, very basic. In ROV, it stands for Remotely Operated Vehicle. If you watch any of the videos from the Deepwater Horizon oil spill, then you're familiar with ROVs. Those are the robots that went down to fix the wells. So they often have a lot of feed coming from ROVs. I actually participated in ROV from 6th, 7th, and 8th grade. This is a picture of me at international competition in Hawaii. The way it works is that every year there's a regional competition that is held in Savannah, Georgia, and it's with schools from, I guess, around Georgia, Alabama, the Carolinas. Actually, Mississippi State University competed against us last year. And if you win regional competition, then you get to go to internationals, which is held at a different part of the United States every year. And 1 year in Canada. This was at the Hawaii International Competition, which was a lot of fun, as you can imagine. And I was actually recognized at the Hawaii competition as the MVP engineer of the entire international competition, which is a huge honor. It was basically an award that was given to 3 students who showed the most expertise during a presentation, during the 15-minute presentation that we had to give. So I continued with ROV throughout high school, and Brendan will talk to you later about the specifics of competition and what exactly an ROV does. He's actually the captain of our team this year. I served my time as captain last year, so it's nice to pass that along. But, this is a picture taken from international competition my freshman year, which was held at the NASA Neutral Buoyancy Lab. This huge thing in the middle of the water is actually the mock-up of the International Space Station that they use to train astronauts. You can see the yellow, I guess they kind of look like cranes in the background is what they use to lower the full suited astronauts down into the water, because this is the easiest way for them to simulate zero gravity without actually having to be in a shuttle, which is incredible to actually work with all of this. We didn't actually work with the space station, but to be there in this facility was incredible. We actually went to the space lab, or the space center, I'm sorry, in Houston, while we were there staying for competition. And we got to watch all these videos of the astronauts training in the pool that we had just been putting our ROV into earlier that day, which was phenomenal. This is just a picture of Brendan and then one of our friends, Wesley. They're piloting the ROV. The way competition works is that we actually have to run the ROV underwater to do specific tasks over the course of 15 minutes. And you have to do so without looking into the pool. It's supposed to completely simulate running an ROV in an ocean environment where obviously you can't just look into the water and see what's going on because it's hundreds of feet. underwater image. Sorry, it's not very high quality, but you can see this right here is our ROV, I guess, for everybody on the sides. It's this right here, this small vehicle. And then this is actually a downsized mock-up of a ship that we had to perform all the tasks on. And each year the tasks that we have to do change. So they are based around real life simulations. So the year after the oil spill, as you can imagine, it was about capping an oil well. We've had some where we had to investigate underwater seamounts, which we're simulating the Logihi Seamount in Hawaii, which is when we went to Hawaii for competition. And this year's actually investigating underwater shipwrecks, which is really exciting because we'll be traveling, if we win regionals, which is tomorrow, then we'll be traveling to Alpena, Michigan, to Thunder Bay, where they have a bunch of shipwrecks that people are constantly exploding. So we're really looking forward to that. And then last year we went to Seattle, which is another incredible trip. This is a picture of the team that went. You can see the team is kind of small. We've ranged. My freshman year we had about 30 to 40 members. This year we have 26 with a huge influx of freshmen. But it's been an incredible experience. RV is definitely the best introduction that I've had to STEM, and I definitely have Ms. Williamson to thank for that. So with my reputation for ROV, I was actually given the opportunity to participate in the very first STEM class that was held at Carrollton High School the summer before my freshman year. So right after I got back from Hawaii for ROV, I was called by Dr. Mark Albertus at the high school asking me if I would like to join in the STEM track. They had recently received a national grant, a national STEM grant. And so they decided to use that money to create a brand new program at the high school, the STEM program. The first year that I was involved, it was actually taught by 3 teachers, one of whom is with me today. But this is Ms. Christy Bradford Hunt. She's a chemistry teacher and the head of the science department. In the middle, that's Mr. William Murray Motley. He's the math teacher, or a math teacher at Carrollton High School. And then on the far right is Ms. Casey Austin, who is also my volleyball coach, and she's sitting right here in the second row and bombard her with questions. She doesn't wear the hat often. But she's also the engineering teacher, so she has taken over the STEM program for the past few years after that first year. The STEM program kind of revolves around VEX Robotics. It's an annual competition where students have to build these smaller robots, not underwater, which was definitely a transition for me. You can see in this picture that's me, and then this is my partner right here in the robot that we built. And it was another great exposure to robotics, especially for people who are just getting into STEM. There's a great learning program that you can go on that takes you step by step through the engineering design process and familiarizes all students with different aspects of STEM. The VEX Robotics competitions are held in places all around the United States and then actually around the world, and then there's a world's competition, which is coming up, I think, in the next few months, which is really exciting. We have some students this year who qualified for Worlds. And then there's also all sorts of shenanigans that goes on in the STEM class, not just the official stuff. So this is the world's largest stool stack. I don't know if it's really official, but I like to think that it is, which is an engineering feat itself. And then also STEM class gave rise to the birth of James Bott, who made history at Carrollton 2 years ago as the first non-human homecoming escort. So we voted our friend Mitch, this very cynical friend of mine, the sweetheart for VEX Club, which is kind of unorthodox in that, for one, he was a guy, which isn't usual, or it wasn't usual for sweethearts at the time. But also he said that the only condition that he would be sweetheart was that he had to be escorted by a robot. And so since it would look ridiculous for one of the little VEX robots to be walking him down the track, we decided to actually create James Bott, who I had the honor of driving along the track during homecoming, and then whenever they called out Mitch's name, James Bott stepped forward and then he would wave at the crowd. It created a lot of great press for the STEM program. James makes lots of appearances at robotics tournaments, and he'll even kind of drive around the cafeteria sometimes, which is always a lot of fun. All students love him, and it definitely generates a lot of interest in the STEM program to see that, it's not all sitting at a desk and learning to use CAD. It's actually, doing things that are going to be fun in and outside of the classroom. So now, through the STEM program at our school, one of the latter steps is the opportunity to participate in the Southwire Engineering Academy. If you're not familiar with Southwire, they're a wire and cable manufacturer based out of Carrollton, Georgia. They're actually the largest wire and cable manufacturer in North America, and they recently acquired Coleman Cable, which is, I think, located out of Illinois or Indiana, one of the I states. Could have been Idaho, I don't know. But now they've actually moved up to, or it's projected they'll move up to the second largest privately owned wire and cable company in the world, which is a huge deal for Southwire, and we're all very excited about it. And so with Southwire comes the opportunity to go and learn and work at Southwire as an engineering intern. The way that I was introduced was actually Coach Stacy Lawler, who's also here in the second row right next to this Casey Austin. He called me, this is the summer before my sophomore year, and was so excited about this new program that they were starting, being able to go and work at Southwire for 2 blocks every other day since we're on the AV schedule, and I was so for it because it sounded like such an incredible idea. And then he broke my heart when he still feels guilty about it today. When right before school started, it turned out I couldn't participate my sophomore year because I wasn't 16. And with child labor laws, there's no way to let students participate. So that was fine because I still got the opportunity to participate both as a junior and a senior, which has been a huge blessing for me. It's been a generous opportunity. The way that SWAYA, as we like to call it, works is that any students can apply, and then 24 students are selected, and that number fluctuates. It went from 20 to 24, and who knows, it could keep growing. And the 24 students are split into groups of 4, so 6 teams of 4. Some of the teams work in the plant groups, and then there are 2 teams that will work in product development. I've worked in product development for 2 years, so this is actually a picture of the plant groups working in what they call the war room. We like to call them the grunts. And then this is a product development team from a couple years ago who the plant teams refer to as corporate scum. So there's definitely a healthy competition going on between the product development groups and the plant groups, which is brought out a lot during the E2Es, which are engineer-to-engineer challenges. Which is when Southwire brings an engineer from any discipline, so we'll often have electrical engineer, mechanical, industrial, and usually there's a general engineering who speaks about engineering as a whole. And then after that engineer talks, gives a presentation, all of the teams compete against each other in an engineering challenge. So whether it's building a spaghetti bridge or learning how to make a circuit for electrical engineering, they hold EDs throughout the year, and then at the end, they add up all the total points, and then there's one team who wins above all. So that definitely brings a fun aspect of Southwire. It's really, apart from all of the fun that's had, it's an incredible relationship between the school and the greater community, just because it's so symbiotic in that Southwire gets so much from the students through their projects. 1, it's free labor. 2, it's not just coffee and donuts. It's real engineering projects. I know that one group last year, Save Southwire, they estimated hundreds of thousands of dollars from their project, basically working on efficiency in one of the lines, which is incredible to hear on all the calculations. My group last year developed a neutral sizing application that's actually available on the App Store, so you could look it up and download it right now if you really wanted to. These are 3 screenshots from the app, and what happened was at the beginning of the year, my boss, Charles Holcomb, he told us, okay, we don't really have anybody to work on this right now. We have an Excel spreadsheet that calculates these things, and customers usually have to come to us and calculate it for them. So what we want you guys to do is we want y'all to develop an app that customers can use so that it takes out the middleman. And none of us had ever programmed an app before, had worked in Xcode, which is the Apple developer. So we said, all right, Charles, we'll do it. And so we spent the next few months teaching ourselves how to program and learning all the aspects of graphic design and things like that. And it's really incredible the way that a group can come together. My team last year, I was actually working with Brendan, which was awesome. And then a friend of ours who was also on the R&D team. And then there's another guy, his name is Chip, who's a football player, has never done anything in engineering before, who turned out to be a huge asset to the team. One, that you have to be charismatic because you have to be able to present your ideas to others, to sell your product essentially, is what you're doing. And then also the skills that go behind it, the programming, time management, things like that. So it's been a huge opportunity for me, not only through school, but also as a career, because it opens up a lot of doors. So outside of school, I'm involved in a lot of other STEM programs, I guess. I went to the Governor's Honors Program, which, if you're not familiar with that, it's a program that's offered 4 weeks during the summer to around 600 to 700 students in the state of Georgia. There's an extensive application process that goes on before it, and students who are selected go and live in Valdosta State University and study in their specific major. So I went to Governor's Honors as a math major. This is my class, GHP 2012 of math majors. And actually, one of my friends in the back row right now is at MIT, and I got to go up and visit him last semester and tour campus, meet with admissions counselors. So it's just amazing the contacts that I've met and kept through Governor's Honors, which my STEM interest definitely opened up all those doors. These are just some more of my dear friends that I've met through Governor's Honors and kept in touch with. It's probably the most valuable networking experience I've ever had. And networking has always been such an adult term to me. Like, networking, I think of like cocktail parties and STEM conferences and things like that. But just meeting all of these people has already opened up so many doors. Over the course of Governor's Honors, I was obviously studying math, and I was a little bummed because I really love the engineering aspect and the technical aspect of math applications. And so when time came to choose the projects that we were going to work on, I teamed up with my friend Elliot, and he had a ton of experience in statistics and probability. He had taken AP Stat, which I'd never taken before, ever, had zero knowledge except for, you put 10 blue marbles in a bag and 3 green ones, and what's the probability of getting blue, which was not the math that we were having to do. And I had a lot of experience in coding and project development, things like that. So we teamed up and created a program that found the best optimal strategy for playing the dice game Shut the Box, which, if you're not familiar with, it's just a very simple kind of dice gambling game. And so that was really, really, really neat to see how those two ideas and both of our knowledges could come together for that project. And then we had to present that project at the end of the summer, which is also very exciting for us. And then towards the end of Governor's Honors, it was a huge, huge honor. I was chosen by the heads of the program to give the academic convocation speech. I think maybe that goes to the biggest nerd because I spent so many hours in the math lab working on my project. And so that was an incredible honor to get to represent all of my peers at Governor's Honors. Another thing that I participated in that same summer was the MIT Ocean Engineering Experience, which is a week-long program hosted by MIT. You have to apply and be accepted to it. It's for students all around the United States and even around the world. The guy next to me in that picture is actually from Guam, and then there's another student from Greece, which is really neat. And we basically spent a week designing and building our own ROV to test in the Charles River, which basically separates MIT from the greater Boston area. So that was an incredible experience. We worked in their engineering labs, in their AUV labs, which an AUV is an autonomous underwater vehicle similar to an ROV, except for it's not controlled by a person. It's its own, I guess, it thinks for itself, it's autonomous. And one of the incredible things was actually, I don't know if you guys have ever seen the Cheetah Bot, which MIT developed. It got a lot of press online for a while. You can look it up, and there are videos all over YouTube. But we were in the lab directly next to the Cheetah Bot lab. So every day walking to go work, I got to see the MIT Cheetah Bot, which was really, really neat. This is a picture of me with our final ROV right before we had done the testing, and then also just some cool math sculpture at MIT. That was a great experience, and it was really nice when I went and visited last semester, I guess, just to go see my friend and kind of already know my way around. And I do keep in touch with some people from the program. I have one friend who's actually at Stanford right now studying engineering, which is really neat. It goes to show that that kind of networking and those relationships really do go a long way. And then the most recent thing that I've been involved in, I guess, is Yale Engineering and Science Weekend. I was contacted, I guess it was about a month or two ago, by an admissions officer at Yale who told me that I was receiving what's known as a likely letter. And a likely letter is kind of the equivalent of an academic recruitment. So the same way that a football coach will contact an athlete and say, hey, we got a spot for you on the team, you know, if you'll take it. That's what they did. Yale called me and said, hey, we got a spot for you in our engineering department, and we would love for you to come to take that spot. So that was an incredible honor, very, very exciting. And one thing that came along with that likely letter is that Yale actually paid for me to fly up and go to the engineering and science weekend. So I got to spend an entire weekend at Yale in the snow, which is a lot more intense than the Georgia snow that we've been getting. I know the host that I was staying with, she was a student. She was like, I hope you're ready for snow. And I was like, my grandmother's been buying me winter clothes because she's worried I'll get out there and won't be warm. But it was definitely a change of pace, and it was very enjoyable. One thing that we did is we got to create a Rube Goldberg project. They split us into groups, and then we had to do this engineering challenge, which was so much fun. We got to work in the CEID, which is the Center for Engineering Innovation Design at Yale, which is a brand new program. They have all sorts of tools and machines there for any students to use, not even just engineering students. I also had the opportunity to sit in lectures by some renowned Yale faculty members. There was Sarah Dimmers, who actually, she had a group of undergraduates doing research with her when the Higgs boson particle was announced at CERN. And they arrived at CERN, camped out there, and were on the front row whenever it was announced, which is absolutely incredible to know that undergraduates have that kind of opportunity. Another person I got to meet was Deborah Fisher, who was on the team back in the 90s who discovered the first multi-planetary system, who proved the presence of one for the first time, which was another humbling experience. And then the highlight of this weekend was probably meeting James Rothman, who is the 2012 Nobel Prize winner in physiology and medicine. He actually gave just the Yes Weekend students, so about 100 of us, a lecture on all the research that he did over the past 30 years and was given this Nobel Prize. And I got to speak with him a little bit afterwards and take a picture to put on Instagram, so that was really exciting. And I guess the biggest takeaway that I've gotten from my STEM experience over the years is that really it's what you make it. It's not just being in the classroom and learning CAD and learning how to use machines and things like that, which are all completely helpful. The technical abilities you need to have in order to survive in the engineering world, but it's really just all the other exciting opportunities that come from that, such as, you know, getting to come here, this little bit of class, and talk to you guys about my experience. So I would say for any true STEM student, they're gonna thrive no matter what environment you put them in, but it's always nice to have the resources to take advantage of that. And at this time, I'd like to turn it over to my friend Brandon, who's going to come talk to you about his experience.
Well, good morning, everyone. Thank you, Abby. So this time, I'm just going to talk about my experiences in the STEM program. So a little bit about me. I'm Brendan Whitaker, and as Abby mentioned, I'm captain of the CHS ROV team this year. I'm also president of what we call the VEX Club. Abby alluded to it earlier. She said that ROV is an underwater robotics program, which just about sums it up. It has its challenges of having electrical components, having to work underwater, and actually this past week we've had a little bit of a troubleshooting party with that. So as captain, I'm a little bit worried about that because we have regional competition in the next few days. And if we don't get past that, I'll be the first captain to ever fail at passing regional competition. So I don't want to do that. But VEX is also one of my, I guess, my joys of high school. I started my sophomore year, and I wish I would have started my freshman year. I didn't know about it my freshman year. And then my older brother, who was a senior when I was a freshman, was doing VEX, and I really didn't see him doing any VEX until spring semester when I was in the band room practicing my trumpet. I used to play trumpet, and he brings in this robot. And him and his friend Kai Hansen, they're sitting in the instrument storage room with a robot on the floor, and they're programming it to drive around. And so I was like, well, what is this? Because this looks like a lot of fun to me. And so then I got involved in it, and over the years, you know, I've just kind of gotten more familiar with the pieces, parts, the program flow, the game, how to design a good working or well working robot, and just kind of advanced until the rest of the club has just kind of designated me as the president. And I could say that I'm more of a figurehead than a true leader. We've got everybody in the club. They all make their own robots. I'm not leading the team on one robot, and they know pretty much just as much as I do. And so that's my experience at VEX. I'm also at SWAYA with Abby. As she said, there are 6 teams. There's 2 in product development and then 4 in what we call SCUP, or Southwire Copper Utilities Product Plan. And so I'm the team leader because I've done it for 2 years, and this is my 2nd year. I'm the team leader of Group D, and we also come up with fun names for our group, so we're Team Dauntless. And so last year in our group, and I'll talk a little bit more about it, I was with Abby, and we made that mobile application. And then this year, we've done a little bit different aspect of programming. We're working with what we call ladder logic in a program called RS Logix 5000. We're programming PLCs, or programmable logic controllers. And then my plans for my future, I just plan on going out to Utah, far away from home, as far as away as I can get. It's not the true reason. I just love it out there. It's great. But I plan on attending Brigham Young University to study to become a mechanical engineer, and then possibly come back to Georgia Tech and finish up as an electrical engineer so that I can do some robotics. But so this is our STEM lab. You can see here on the left that we've got lots of computers in there. Maybe you can. It's not a great image, but we've got about 30 to 35 computers in our STEM lab, and then 4 projector screens. So as Ms. Austin is sitting at her desk on her computer that she can draw on, she's teaching all the students in STEM 1 that this is CAD, and you have your object orientation cube up in the top right, and she points to it, and they see her cursor, and so that all the students who have no idea, maybe what a computer is, that's how they're going to manipulate a 3D object. And so that gets displayed on each of the 4 projectors. You can see 2 here, and then there's 2 on the other 2 walls. And so it's a great learning environment because you can see everything that's going on. And then also in the small quad picture, you can see in the top left we have a robotic arm. Top right we have a CNC mill. Bottom left a materials buster, that's super fun. And then in the bottom right we have a laser engraver, which is a really neat experience. So a little bit more about the computer lab. Like I said, we have about 35 computers, and each computer has a bunch of different programs on it. Some of these programs are like Revit, Inventor, Autodesk, all those programs, AutoCAD. And then on certain specialized computers, we have some things like CorelDRAW. CorelDRAW is the program that the laser engraver uses, and you can import files from AutoCAD that you've drawn up in a little bit easier of a format, and then import those into CorelDRAW. And then that program will then take it and put it into something, when you hit the print function to our Spirit LS laser engraver, that it's going to print it out on your wood or your plastic or keychain, whatever you want to do on this laser engraver. There's lots of good opportunities in there. I don't know if you can see real well, but there's a guy standing right there about the middle of the screen. Right behind him, there's a door. It's the storage closet. And that's where I started to learn my STEM experience. I was the child back in the closet building my robot. I was a little bit of a shy freshman, didn't know too many people, and after schools, my older brother would be out in the main room working on his program for his autonomous robot, or on his driver control program. I would be back in the back, just taking pieces of metal, sticking them together, and putting a screw in it, going, "Look, Justin, look what I made." And he would be kind of proud of me, but that was my room back there. There was lots of pieces, parts everywhere, and it was a great experience for me to just have everything that I could possibly want to build. It was like just a giant Lego box that I just got submerged in. So that was really fun. And like I said, there's lots of projectors, so that if we want to express an idea to the rest of the class, we go to Ms. Austin's computer, and however large a group we can fit in there, standing or sitting, everyone will be able to see everything that we've got just fine. And then it's also interactive. We've got a little bit of Promethean technology and we can draw on it and make adjustments. So for ROV, it's really nice because as we're brainstorming, coming up with frame ideas, all we have to do is get one person to go up to the screen, draw on it, and then the rest of us sit down and go, no, that's stupid, don't do that. And then we go up there and draw something else, and then our ideas get shot down until we finally have a working frame that everybody can agree on, at least in some part. So some of our toys, and I call them our toys because I do think that they're toys, they're really fun to me, but our robotics arm. This is super fun because you get to see a little bit of what a real-world engineer would do, say, in a large product plant. You would have multiple products running on a line, and you can't see it right now, but there's a conveyor belt that sits in front of this robotic arm. So the conveyor belt runs at a certain speed. It can stop or start whenever it needs to. And then the robot, or the arm, that lowers and grabs at certain speeds and times, and you just program it to do whatever you need it to do. And so it's a challenge every year for, I believe, the STEM 2 class. And they have these blocks that sit on the conveyor belt. You tape out where they sit so that they sit in the same places every time so that you don't have bad programming. And so they sit in the same places, and it moves, and then it stops in a certain place, and you have to program the arm to lower, pinch, raise, twist, and then place it down somewhere. And so it's a real great experience for kids who maybe don't really understand what a robot is, or how it works, or what programming is like. They can look at this and see, okay, this is easy. You just move the arm and say set point, and then it's going to go to that point every single time. And it's really nice because it's something that's fairly simple to grasp, and it's fairly simple to learn. And so that's really nice. And then to the right is our CNC mill. This is a small-scale version of another machine that we have, a CNC router, and it was the predecessor to the router. So the head will remain just constant, and it'll spin at a certain rate, and it can cut, we have wax blocks, it can cut wood, it can cut metal, and you just set different rates or speeds of the table to get it to move, to get it to not break the bit. And sometimes we mess up and break bits, but that's okay because it's in such an environment that there's a lid that lifts or that lowers down and protects everyone from flying shards of metal, which is kind of nice. And so it's such a great environment just to learn how to use a mill or the CNC technology and learning G-code. And we have programs that will actually do most of the coding for you. You say, I want it to go 3 inches to the left, and it'll write the G-code, move XY coordinates, such and such. And so that's really nice for us. You don't have to get too involved into G-code and get frustrated when you have 3,000 lines and one of them gets messed up and you end up cutting off the block. And sometimes that happens with the program anyway, but we work with it, and it's super fun. This is what I learned my first programming and CNC technology with, was this mill. It's kind of frustrating sometimes, but still super fun. Some of our other toys, like I said, the Materials Buster, that one's super fun. We actually have, right now, you've got the hardness tester on there. It has something that you put in there, and it has a diamond tip on it. It's about a 45-degree angle, and it'll press down with air pressure until it feels the resistance, and at a certain resistance level, it's going to say, okay, I know how hard this material is. And so we've got a program that'll tell us how hard the material is, and it came with a kit of aluminum pieces that were different alloys, and so we could test how hard each alloy was. And there's also some other bits in there where you have a tensile strength tester, and so it'll latch on to 2 different ends of it, and it'll just start pulling until you hear this gunshot basically, and it just goes wham, and just breaks apart, and then it'll tell you what the tensile strength of this is. And then there's also a hole press that does similar to the hardness test. It'll do that. It's just a large block, and in the base of it, it's got a covering where you slide in your material, and then it'll press down until it punches a hole in it. And so it kind of tests where the breaking point is, I guess. And so we've pressed a couple things and made some fun jewelry, I guess, some pennies and quarters and things, and it turns out pretty fun. It's hard to get it, just right where you want it though, because it's all covered up. But then the laser engraver. The laser engraver is my second favorite toy in the entire STEM lab. It's super easy to work with, and it comes out with the most just high-def engravings that you could ever think of. And when I thought of laser engraving, I thought, well, geez, I'm going to burn a piece of wood until there's nothing left. But that's actually not it. There's different speed and power settings on the actual program where it ranges from basically 0.1 to 100. And so we can set that, and for wood, you can either get it where you're catching the wood on fire and going, Miss Austin, hit the stop button quick. And that's lots of fun in the STEM lab, is there's smoke getting through the ventilation. That doesn't smell quite what it's supposed to be. But so we've got the laser engraver, and we can program on, or I guess rather draw on AutoCAD, say our name. And we can put a dog tag in there that we want to have for a necklace, or that someone else wants for a necklace, and we place that in there, measure our dimensions of that dog tag, and then we're going to input that on CorelDRAW, import our CAD file, size that down, and then export that to the printer, and it's going to do the rest of the work besides basically your focusing of the laser, because it's got its different focal points for different heights. And so that's been a real great experience for me, especially because I've been able to learn from my mistakes of burning wood and burning plastic and the wrong power and speed settings and just ruining projects that I should not have ruined. So you can autofocus the laser. It has an autofocus pin, or you can focus it by sight, and that's kind of what we've had to do recently. We had a little bit of a problem with one of the students' materials busting the autofocus pin, I guess you could say, and so that's a little bit out of commission. But you can see here in the picture that we have VEX at the top. It's a VEX trophy, and instead of purchasing a bunch of trophies for $100 for our VEX competition, we're able to purchase these plaques for much less the cost and laser engrave them ourselves. And so we got a couple of the students in STEM to draw up what they thought would be a great trophy, given the parameters that we needed judges award, we need 4 tournament champions, and we need a programming champion. And so we gave them those parameters, and they draw up these trophies, and then they got to learn the entire process from AutoCAD to CorelDRAW to laser engraver. And so there's lots of great experiences there, and it's all located in the STEM lab. We don't have to go over to another building or get any kind of special permissions. And it's very safe. There's all sorts of precautions on the laser engraver, and then Ms. Austin's got her watchful eye, and then there's the senior people who have done this before, and they're watching and going, no, that's too far up, you're just going to burn the wood. So that's a little bit about those toys. And then this is what we call the Hulk. He's huge and he's green, so we call him the Hulk. And so this is our CNC router. It's different from the CNC mill because it has a 5-foot by 5-foot table that we can position our workpiece on, and then either engrave or cut through a piece of wood, or we've also done a granite block and tried to engrave a Trojan head on there. Granite just chipped, so it wasn't too great of an experience, but still fun to know our limits. But generally wood is what we do. Recently we've been making a lot of sports plaques where you would make an oval and then cut out the Alabama A or the Georgia G or whatever people would request, and they'd tell you what they wanted. And we'd have a STEM student saying, okay, this is the Alabama A. They get a picture from the internet, paste that into AutoCAD, trace it out so that it looks just like the A, and then we're going to export that file in the format of a DXF file. Standard AutoCAD file is a drawing file, or a DWG. So we just had to make sure that everybody knew that you've got to export that as a DXF. That's what our Aspire program for the router is going to take. So once we export that as our DXF, we take that into Aspire. Then Aspire is the program where we convert your drawings, your just lines into tool paths, because that's what G-code can take and say, okay, I know what to do with this. And so we export then after we have our toolpaths, we export that to a program called Mach3 vCarve Pro. And that's what our router, it's called an easy router, that's what the router takes. And it's called an easy router, but it is not an easy router at first. After a little bit, you learn its ins and outs, and you get to know that there's certain things that you have to do. You have to reference all home first before you start putting your code in, or before you start moving your work piece to get it to the right place. And that was something that frustrated us for a long time, because as you open up your program, you import your code, and then you move the tool head to get it to your origin where you want to start the cut. And then you hit start, and it says reference all home. You're like, oh man, so you hit reference all home, and it goes to the left to 0 is X, and then hits the limit switch, comes back, and does the same thing for Y and Z, and then you've lost your zeros. And then you've got to go and do it again. And so there's just lots of little ins and outs about the router that we've learned over the years, and also that it only takes certain kinds of computers. We got it a couple years ago in the beginning of fall semester, and we weren't able to work with it until spring semester because we couldn't find a computer that would interface with it. And so we actually had to fly, or I guess the company had to fly the actual designer of the easy router to our school and tell us how to work it, tell us what kind of computer we would need, got it all set up for us, and we started working with it. This is actually my favorite machine in the STEM lab. It's lots of fun because there's really no limits on how complex you can get with this, besides full 3D rotation of the head. You can do what's called a pocket toolpath, and where you won't cut all the way through, and we've done some stuff with that. And then you can do a full profile toolpath where it cuts all the way through, and you can interface both of those to do whatever you want. And it's as easy as you want it to be, as long as you come in with an open mind and someone there to teach you. All you need to know is that here's the toolpath. I click on it, hit toolpath, and then tell it where to go, and it's going to do it. And so it's really simple for students. It's pretty low stress, and especially as I've had the opportunity to teach a couple people how to use the router, especially through ROV, that you just kind of have to work with it and do dry runs. Instead of cutting into the wood, you've got to watch it, sit with your hand on the E-stop button, and watch it go above the wood. And so if it starts doing your circle like this and then goes way over here, you know that you're not making a circle. And so you hit the E-stop button and start over. And so this is one of my favorite things about the STEM program. It's just the availability of tools to learn on, things that are used in real-world applications. And it's such a great thing to learn on something like this in a controlled environment at school with Ms. Austin watching over you and with senior members of the STEM program who know what they're doing, to watch you and say, before you make a mistake, that's going to be a problem. And that's what's gone with me, and now I'm teaching the freshmen, that's going to be a mistake, you don't want to do that. So now a little bit about VEX. Like I said, I'm the president of the club, and you can see here in the picture on the left, this is one of the early prototypes of my bot. I've got a simple bar lift with an intake on the front, and we had what were called buckyballs for this year's game of toss-up, and we intook those into our intake, and we had to score those into an 8-inch cylinder that was 24 inches high. As you can see on the right, we've got a little bit of the VEX logo, and then there's 3 different motor sizes. Starting on the right, there's the oldest motor type that we had, and it's a 3-wire motor. And so it wasn't running direct current, and it was a little bit harder to interface to test. You actually had to have a program that when you flipped the bot on, that it would just run motors to test it. Whereas with the 2 on the left, they're 2-wire motors, and they can run direct current. You can just plug them into a battery, and they'll run. So if you want to run it reverse, you just flip the pulls around. And so in the middle, you have what we call a low-strength motor. It's just a smaller motor. It's not necessarily any worse. It's just for different applications. And then on the left-hand side, we have the 393 high-strength motors. And these motors are pretty much the envied possession of all the teams. We're only allowed 10 motors, and so we all try and get our hands on the first 10 high-strength motors that we can find. That's because generally you want to run with as much power as you can and as little resistance or strain on the motor as you can. So getting these high strength motors really improves the bot a lot. So here's a little bit about the game. For this year at least, it's called toss-up. As you can see, there are two different sized balls. They're what we refer to as beach balls, and then the small balls are called buckyballs. We just recently got our field in for a competition, and the setup of the field is right here on the right. You can see that teams stand on the outside of the arena, and there's an alliance of two teams. Two teams, or two bots versus two bots, and you go at it, and you have, in this year's game, it's especially challenging because you have three different sections of the playing field. There's one section that's separated from the other two by a bump. It's a 2-inch high bump with little ramps leading up to it. In previous years, we haven't had to worry about the clearance of our chassis. This year, that was a big problem because if you have an 18-inch long robot with a wheel on the front and a wheel on the back, you get the front wheel over and the middle of your bot is going to be stuck and you'll be out of commission for the rest of the game. And we've had a couple bots that have had problems with that this year, but we've thankfully overcome those. And then on separating the second and third areas, there's a 12-inch high bar. And so not only do we have to get over an obstacle, but we also have to travel under an obstacle. So we have to limit our bot in two ways. We have to have our chassis up off the ground by at least 2 inches, or have a set of multiple wheels. And then we also have to be compressed to a small enough size that we can get under 12 inches. And then I guess the most frustrating part of getting under 12 inches is the cylinders that we score on the far side of the arena are 24 inches high. So we have to extend to over twice our height to be able to score any points, or I guess considerable points. So that's our VEX program, and in past years they've had other games that are similar to this. Same alliances, but different game types. ROV is a little bit different from this. We have underwater components, so we have to have waterproofed cameras, waterproof motors, and waterproof thrusters, the manipulator, everything. And that can be a problem if you don't want to buy a $5,000 manipulator, you don't want to have to buy a $1,000 thruster or similar materials. So ROV is sponsored by MATE, it's the Marine Advanced Technology Education, and they sponsor regional competitions for certain regions throughout the world, and then an international competition. Abby touched on it earlier. ROV stands for a remotely operated vehicle. It's remotely operated through a tether rather than what you would think of as a remote-controlled helicopter. The competition has 4 parts. You have the mission run, the engineering evaluation, a poster presentation, and then a technical paper, or a technical report, as it's called. And each of those is roughly a quarter of the overall score. So even if you don't do well in your mission run, you can still make up for it in your other aspects of the competition. So it's a lot nicer than VEX, where VEX you only have one shot at doing well in the competition. So commercial ROVs, they function in a number of roles. I've got some listed here. Ship cleaning was one that I hadn't thought of before, but they actually can go around and scrape off the mussels that accumulate on the ship. And then it even gets to something as exciting as treasure hunting. So that's a little bit fun, just a little bit of fun applications for ROVs. And then Abby also said that the Deepwater Horizon's oil spill was managed by ROVs. We actually simulated that competition with our ROV 4 years ago. And so that's something nice for us because we actually get to see what an application of an ROV is in the real world, what we would do if we were to be an engineer on a commercial ROV. And then the bottom point, it's largely unregulated as to things like your size, your motor constraints, but safety is also something that is very important. We have a